Gentleman from Florida, Dr. Nils.
Thank you very much, Chairman Weber. And I want to say add my thank you to the panel and underscore my personal belief in how important all your work is. I've visited Dr. Bobby Kasthuri's lab, great fan of your work and your energy level. Dr. Yelick will be visiting you in the near future, so that'll be fun too. I want to focus on the niche in big computing, which is artificial intelligence, and I apologize I missed that hearing earlier. But it was near and dear to my heart. I think we all see many potential benefits of artificial intelligence, but there are some potential problems, and I think it serves us to face those as we're having this virtual love fest for artificial intelligence. And we've known this since at least the 60s. I mean, the Isaac Asimov robotic novels and the robotic laws, the 3 laws of robotics, which I have in my printout, the copies of, in case anybody doesn't remember them. I bet this group does. But what I would do is I also, by the way, was looking for guides for artificial intelligence, and I came up with the 12 Boy Scout laws too. So I don't know how that responds. So I want to offer some quotes and then get some thoughts from you. And these are quotes from people who are recognizably smart people. Stephen Hawking said, "I think the development of artificial intelligence could spell the end of the human race." Elon Musk, quoted several times here, said, "I think we should be very careful about artificial intelligence. If I were to guess what our biggest existential threat is, it's probably that." Bill Gates responded, "I agree with Elon Musk, and I don't understand why people aren't concerned." And then finally, Jane Talon, one of the inventors of Skype, said, "With strong artificial intelligence, planning ahead is a better strategy than learning from mistakes," and went on to say, "It really sucks to be the #2 intelligent species on the planet." Just ask the gorillas. So in everybody's handout, you have a series, a very brief summary of a series of experiments run at MIT on artificial intelligence. The first one was named Norman, which was an artificial intelligence educated on biased data, not false data, but biased data, and turned into a deeply sociopathic intelligence. And there was another one, Tay, which was really just an artificial intelligence Twitter bot, which they turned loose into the internet. And Tay was, I think, it wasn't the intention of the MIT researchers, but people engaged with Tay and tried to provoke it to say racist and inappropriate things, which it did. And there's some other experiments from MIT as well. So I want to note, like Dr. Kasthuri, I have sons that are more clever than I, but they are not virtual supermen, nor do they operate at the speed of light. So, you can still, there's ways of working with them. I'm not so sure about that with artificial intelligence. My question first, what are the implications of our future where black box machine learning, the process can't even be interpreted? Once you get several layers in, we can't even interpret it. What's the implications on that to you, Dr. Kasthuri, and Dr. Yelick second?
Congressman Dunn, thank you for the kind words to start. And I actually suspect there is a reasonable concern that the things that we develop in artificial intelligence are different than the other things, like our children, because their ability to change is at the level of the speed of computers as opposed to the speed of our own. So I agree that there's legitimate cause for concern. I suspect that we will have to come up with lessons and safeguards the same way that we've done with every existential crisis, the discovery of nuclear energy, the application to nuclear weapons. As humans, we do have some history of living on the edge and figuring out how to get the benefit of something and keep the risk at bay. You're right that if algorithms can change faster than we can think, our existing previous historical safeguards might not work. To the specific question that you asked about the non-interpretability, for me, without knowing what the algorithm is producing, how do you innovate? If you don't know the fundamental nature of what the algorithm is, its principles for how it comes to a conclusion, I worry that we won't be able to innovate on those results. And this is, interestingly, perhaps as a thought exercise, what if a machine learning algorithm could tell me, could collect enough data to make a prediction about a brain, about your brain or someone else's brain, that was incredibly accurate? would we at that moment care how that machine learning algorithm arrived at its conclusion, or would we at that moment take the results that the algorithm produces and just go on with it, in which case there could be a missed opportunity for learning something deeply fundamental and principled about the brain.
And very quickly, Dr. Yelick.
Well, I agree with that. I think that these deep learning algorithms, which have these multiple layers, which is why they're deep, they have millions perhaps of parameters inside of them, and we don't really understand when you get an answer out why all these parameters put together tell you that that's a cat and this one's not a cat. And so that may be okay if we're trying to figure out where to place ads, as long as we give it unbiased data about where to place the ads so the right people.
But it might be more problem if it was flying a drone swarm on attack someplace.
Well, where it's a problem is if I'm a scientist, I want to understand why. I don't. It's not enough to say there's a correlation between these two things. And if the drone is flying in the right place, that's really probably the most important thing about some kind of a controlled vehicle. But in science,
we're dangerously close to being way, way, way over time. So I better yield back here, Mr. Thank you very much. I appreciate the chance.